Welcome and thank you very much for joining. I'm Elad, as we said, and actually I'm very, very exciting. So I hope that you will forgive me. So what we will do today, we will discuss the project. I will start with the story of Project Debater, and I will tell you the story of the debate that we did and how we changed and developed from the debating setting to other to a tool that enables to solve many problems. So let me start. So what is a debate? Debate is a human activity each of us performs every day. It is also studied and formalized starting with the ancient Greeks, and it is practiced today in many competitive settings in schools and universities. Project Debater became the first AI system to successfully compete with a human in a full live debate. It was demonstrated in February 2018 when it took Mr. Harish Natarajan, one of the world's leading professional debaters, in an event held in San Francisco. Today, I will tell you the story of Project Debater from its inception and up to what we call the Grand Challenge. It's live debate against Natarajan. I will show you a segment of a few minutes from the debate so you can have a first-hand impression of the system. And then I will describe the underlying technologies and explain how Project Debater relate to other advancements in the AI landscape. After the debate, we aim, as I said, to extend the use of Project Debater technologies to other natural language problems, and we split it into a set of separate services. Such each service is a single Lego brick, and by combining this brick together, one can build very complex application that addresses different use cases. We call this set of services the Project Debater Early Access Program, and in the last part of our discussion today, we will discuss this program. So let's start with the story of Project Debater. Project Debater continues the tradition of IBM Research Grand Challenges. Just a second. Oh, the screen is okay. So what is Grand Challenges? These are long-term, ambitious projects which aim to advance the state of the art as well to redefine what people expect that machines can do. IBM has had a few Grand Challenges in the past. In 1997, an IBM supercomputer named Deep Blue was the first computer to defeat a world champion in chess when he defeated Garry Kasparov, then the reigning world chess champion. 14 years later, in 2011, the IBM Watson system beat the all-time human champion in Jeopardy trivia TV show. A few months after that, John Kelly, then the head of IBM Research, sent an open call to the entire IBM research community, asking them to suggest the next Grand Challenges. Dr. Noam Slonim and a few colleagues submitted a proposal to build a system that could debate with humans. This seemed then far-reaching and questionably achievable. But after a long process of assessment by the review committee, Project Debater was given green light to proceed. Next came years of development by the team that you see here in the picture, based on the Haifa Research Lab in Israel, together with significant joint collaboration with other IBM research labs in other countries, including Dublin, India, Yorktown, and China. The system was finally demonstrated in February 2018. The event was co-organized with Intelligence Squared, an acclaimed US TV show, which held a debate on current affairs with leading thinkers and policymakers. The system debated Mr. Natarajan, a finalist in 2016 Debate World Championship. Harish never debated the system before. The topic of the debate was whether we should subsidize preschools. This was a hot topic in California because at the time the governor of California suggested such proposal. The format of the debate was as follows. Project Debater was assigned to support subsidizing preschool. It gave a 4-minute opening speech, and then Harish gave his own 4-minute speech after that, in which he presented his position of opposing subsidizing preschool. Then there was a round of rebuttal speeches, where each side has a 4 minutes to address the point made by its opponent And finally, there was a round of 2-minute summaries. So overall, each side has to deliver 3 speeches, altogether spanning over 10 minutes. 2 points I would like to emphasize. First, the debate was full automatic. There was no human intervention during the event. The only part that was explicitly added for the event was the welcoming message that the system gave to Harish that was scripted in order to increase the fun of the event. And second, the topic was selected from the test set of topics based on the assessment of the chances that to have a meaningful debate. I mean that the system never trained on the topic. The system could debate many topics, but not all. And specifically, in order to debate, the system needed to cover, the topic must be covered well, both in Wikipedia and the corpus of data that we use to mine argument for the speeches. So with that in mind, let's view a few minutes from the grand challenge event.
Greetings, Harish. I have heard you hold the world record in debate competition wins against humans, but I suspect you've never debated a machine. Welcome to the future. When we subsidize preschools and the like, we are making good use of government money because they carry benefits for society as a whole. For decades, research has demonstrated that high-quality preschool is one of the best investments of public dollars, resulting in children who fare better on tests and have more successful lives than those without the same access. Secondly, a few words about poverty. While I cannot experience poverty directly and have no complaints concerning my own standards of living, I still have the following to share. Regarding poverty, research clearly shows that a good preschool can help kids overcome the disadvantages often associated with poverty. The OECD has recommended that government subsidize pre-primary education to boost performance in poor areas.
Well, thank you very much, everybody. It's a pleasure to be here for this historic event. And it certainly was a pleasure to listen to Project Debater. There was a lot of information in that speech and lots of facts and lots of figures. The problem, though, is the reality of subsidizing preschools is one which does not deal with the underlying problems in society. If you massively increase the number of people going to preschool, they're all going to be the ones going to the high-quality preschools. In a competitive environment at the age of 3 or 4, when you're learning that that other child is potentially better than you, when you realize you aren't necessarily as talented as someone else, that huge psychological damage for many children may mean that preschool is actively harmful.
Among other things, I think Mr. Natarajan suggested that preschools should not be subsidized because this will reduce their quality. I would like to offer a different view. I disagree with my opponent. Subsidizing preschools will have no negative effect on their quality. If anything, the opposite is true. One of many reasons is that subsidizing attracts more skilled and qualified people to the field, improving the quality of preschools for all. My opponent claimed that preschools are harmful. I believe my argument suggested that the benefits outweigh the potential disadvantages. I touched upon 3 issues: children, students, and crime. Specifically, I noted that preschool education improves children's development. In addition, I suggested that attending preschool helps students succeed. And a final point to consider is that preschool can prevent future crime. We should subsidize preschools. Thanks for your attention.
If you want to know more about the story of the development of Project Debater, it is worth to know that it captured in a documentary film presented in the Copenhagen Film Festival last year, and it is also available to viewing on the web. You can see here the link, and if you are interested, you are welcome. A fair question after any competitive match is who won? This is a very good question, which highlights one of the unique aspects of the project. In chess, Go, and even Jeopardy, it is very clear who won. But in debate, it seems very subjective. So how will you determine the winner? Debate club have faced this problem for centuries. For example, in Cambridge Union Debate Club, one of the oldest in the world, they have devised the following scheme. They have three doors to enter and exit the debate hall. If before the debate you support the discussed motion, you enter the ayes door. If you are against the motion, you enter through the noes door. If you are undecided, you go through the middle door. Similarly, after the debate, you exit through the door representing your position after the debate. And then they count how many people enter and exit each door. And then they count the difference, how many people change their position. The winner is the side that was able to sway more people from the opponent's side to his or her side. Intelligence Squared use a similar scheme, but of course they use electronic voting and not physical doors. We follow the Intelligence Squared method, and here you can see the result of the live event. We can see that before the debate, 79% of the audience were supporting subsidizing preschool, while 13 were against. After the debate, 62 were supporting subsidizing preschools, and 30% were against. So Harish won this debate by this measure. He swayed 17% of the listener to his side. But we also ask another question. Which side better enrich your knowledge? And here we had a conclusive result. Project Debater was able to provide more relevant information than Harish. And this picture is consistent with what we saw in other debates. Usually, more often than not, but not always, the professional human debater was more convincing than the machine. But almost always the machine was able to better enrich the knowledge of the audience. And for us, the purpose of the competition was mainly to demonstrate the developed technology and its applications. The fact that humans still have many advantages over machines. But on the other hand, machines can augment and enhance human. I think that this is a narrative we can all stand behind. And a current thought that many people have when viewing the system is that either that it's all completed scripted, or that they really don't understand how computer can do that. And in the next few minutes, I will try to give a basic overview of how the system works. So let's start with reviewing the inputs and outputs of the system. The system received as input a single sentence, the motion. We should receive preschool in the event. And from that, it generated the opening speech, which was communicated via expressive text-to-speech box. The rebuttal and summary speeches also took as input the opponent's speech, which was recorded using a microphone, and then transcribed to text using Watson commercial speech-to-text service. Now, let's understand how the opening speech was constructed. There were two main sources of content for the speeches. The first one was mind argument. It was based on the following idea. We can find arguments that relate to the topic in a huge corpus, and then use this argument in the speeches. In order to achieve that, we index ahead of time Wikipedia and LexisNexis. LexisNexis is a huge source of over 400 million articles from newspapers and magazines. We index these sources in a sentence level index this index includes NER annotation and name entity recognition annotations and wikifycation of the text. When the system got a motion, it first queried for relevant sentences in the index. So after this step, we have a list of sentences that related in some way. They have keywords that related to the topic. Then the system used claim detection and evidence detection. And these are classifiers that aim to identify arguments that relate to the motion out of the other sentences. The difference between claim and evidence in our terminology is that claim is short and simple argument, and evidence is a claim that cites a scientific research or expert opinion or something like that. And we have these classifiers, and after this step, we have only arguments, only sentences that our system predict that they are arguments that relate to the topic. Then the system performs sense detection on these arguments and split them into pro and con arguments. And this is a very critical step because mistake here will lead the system to argue against its own position. The second source of content is the argument knowledge base. The main idea of it is the observation that in many debates, there are generic arguments that can be used. For example, for both motion, we should ban alcohol and we should ban cannabis, we can claim that banning of something will create a black market. Using this observation, we created a database of generic categories like banning, environment, subsidies, and so on. And for each category, we wrote ahead a set of arguments that relate to that category. And this knowledge base was written with the help of expert debaters, since this kind of knowledge is exactly part of what they do in their debate classes. It's a tactic that every professional debater knows, that he don't need to understand the exact topic, but there are some arguments that he can use if it's related to the topic. And then we built an automatic machine learning-based classifier that predicted which categories were relevant for a given motion. So when we got a motion, the system take it, run the classifier on it, get the related categories, and then take the arguments of these categories and use it in the debate. Please note that fixed rules for this classifier will not be enough. For example, you cannot blindly say that all bans will lead to a black market. Why? For example, if you take the motion, we should ban flag burning. So of course, you cannot say that the banning of flag burning will cause a black market. So now we have two sources, and we need many arguments, and now we need to meld them into one coherent speech. And for that, we had a component that we called it the debate construction component, and it used the inputs from both the main claims and evidence and the principal arguments from the knowledge base that were relevant for the topic. And the first step was to find similar arguments and remove the duplications, remove a similar argument, because many times you have the same argument more than once, even in different phrases. The second stage that we did was to cluster together arguments that discussed similar themes in order to have a well-structured speech without jumping from one topic to another. And in order to do that, we used text clustering algorithm. Then the next step was to identify the main theme of each cluster. The theme was a single concept. And when I say concept, I mean a title from Wikipedia that was unique to each cluster. And we also had a component that did that. So after all these steps, we had a list of cluster. In each cluster, we had the arguments for our stance that relate to the topic and a theme that described the arguments in this cluster. And then the next step was to assign the clusters for the three speeches. And many times we have more cluster than time. So we pick the best clusters and assign them to the speech. So let's think about the first step, the opening speech. The next step, we have clusters. Now, what we did was to select the best argument in the cluster, because again, many times we have more arguments to say than time. And then we rephrase the argument and add connecting text in order to improve the fluency of the speech. And the last step was to send it to expressive speech-to-text module in order to deliver the speech. And here you can see the opening speech delivered in the Grand Challenge event. The different colors you see designated the various parts we discussed. Project debaters start describing the issues it's about to discuss. Advancement, poverty, and these are the themes that I mentioned before. Then we have paragraphs with the argument relevant to each theme. And these are either claim in pink or longer evidence arguments in red. And as I said, the difference is that evidence contains research result or expert opinions. And you can see how the mind information combined into one fluent narrative. Let's hear just the beginning of it in order to experience it.
There are two issues I will elaborate on now. I will start by explaining why preschool is an important investment. I will also say a few words about poverty, and I will end by discussing some other issues that show the positive aspects of preschools. Regarding investment, nature-based preschools are powerful interpretive programs as well as lucrative business decisions. As I mentioned, preschool is an important investment. For decades, research has demonstrated.
Okay, so let's continue. So finally, I want to touch one of the most difficult parts of the system, which is the rebuttal capabilities. As I mentioned, the first step in the rebuttal was to transcribe the opponent's speech into text. The main rebuttal approach was trying to anticipate the claims the opponent might say, and then check if the opponent actually said these arguments. There were two main sources for potential claim the opponent might say. The first were principled arguments, like ban will lead to black market. The second are specific claims we extracted from the corpus, which were identified as an opposing stance to ours. And since the opposes our stance, it is plausible that the opponent might say them. The system then analyzed the opponent text for these claims and tried to say whether the opponent say them or not. Note that the claim don't appear word by word, and that the system must understand if the opponent said mean it even without say it exactly. For example, if the opponent said prohibiting the sale of cigarettes will cause an increase in illegal trade, is equivalent to say a ban will lead to a black market. And once we're confident that the opponent made a particular claim, we can rebut, either by using a counter principal argument, if it came from the principal argument, or by trying to match with the counter evidence from the corpus, or simply stating that we disagree. It's also a valid rebuttal. The final decision on what rebuttal is made depends on the confidence that the system has in the analysis. Obviously, there are many details that we didn't discuss, but I hope this gives you an overview of how the system works. To summarize, there were three main challenges that the system had to overcome. First, the system had to integrate this sparse information from a massive corpora into a coherent speech, delivered with clarity and sense of purpose. Second, the ability to listen and identify the main claims of the opponent, which were hidden in a long, continuous spoken speech in real time, something we call listening comprehension. Project debater had to understand the gist of a 4-minute long speech. And third, the system had to model the world of human debate and effectively utilize it in the debate. As I mentioned before, the debate setting is different from the past challenges. I want to highlight 3 points. First, in most game settings, the next move is selected from a set of known possible moves. In debate, there are innumerable ways to proceed at each point. Second, we already saw it's hard to define who won. Moreover, it's impossible to simulate the opponent, so reinforcement learning strategies like debating yourself will not work. And third, because success is subjective, has to be measured by human standards. This is unlike board games, where the system can choose any tactic it wants and find the most beneficial way to win, even a tactic which is not understandable for humans. These differences are more like the problems we face as humans in our daily lives. And thus, we believe that we move the AI from its comfort zone to the real world. And that's why I think it was very important. One another point that I want to touch is that the question why we did that. So With such large effort in both time and resources, it is reasonable to ask why. Why to pursue such grand challenges? And I think that the answer is by setting such ambitious and long-term goal, we made a clear beacon which focus our team on, and it led to advancement in science, definition of new research domain, and new commercial directions and real-world application, like I hope that you will see in the second part of my webinar. Over the years, our team published over 50 papers in the top natural language processing conferences and defined several new research areas. And this include an article described the full system that has been recently featured on the cover of Nature. Moving forward, after the grand challenge, the first application of the debater technologies was speech by crowd. In the original system, we presented a summary of the pros and cons of a specific topic based on large corpus of written text. We ask ourselves, what if we could take this approach and apply it on people's opinion? And that's exactly what we did in speech by crowd. And so let's say you are a decision maker and you would like to get input from different stakeholders before making a decision. For example, you can be a company manager seeking input from your clients, employer seeking input from your employees, or you could be a government official seeking input from your citizen base. And the question that we want to answer is how you can collect this input, analyze it, and consume it. So speech by crowd allows collecting textual inputs from hundreds or even thousands of participants on some topic or question, and create a concise narrative summarization for both pro and con sides that expressed by the participant. And it was demonstrated in several venues listed here on the screen. For example, in September 2019, it was used by the city of Lugano in Italy to obtain the input on the question whether we should support autonomous cars. Another example of speech by crowd was that debatable television series presented by Bloomberg Media in collaboration with Intelligence Squared. The show hosted 3 debates on topics like we should redistribute the wealth, and Project Debater Technologies was used speech by crowd to present the position of the audience. Let's see how it worked.
I want to move on to the next part of our debate, and what we're going to be doing now is actually bringing in our global audience. Over the past few weeks, thousands of people around the world alerted to this debate, submitted their point of view by making an argument on the topic. We will use now artificial intelligence to help us understand what matters most to this global audience, what arguments and ideas that they thought were most important. And we did that by turning to IBM Watson, which uses AI to scale public opinion. Let's take a look at how that works.
First, people around the world submit their arguments online. Then, the AI assesses the quality of the arguments, filtering out any irrelevant submissions, and sorting the remaining arguments into for and against. Next, the technology identifies the recurring key points, ranking them based on their quality and their frequency. Finally, the AI creates a coherent narrative of the strongest and most prevalent points for both sides of the debate.
Okay, and now we get to hear it, a selection of the key points and arguments that our global audience, thousands of people around the world, thought were most important on this topic. So let's go to that.
Hello. Ahead of this debate, more than 3,500 arguments were submitted on the motion it's time to redistribute the wealth. The following analysis used AI models to identify the critical key points made by each side. 56% were for redistributing wealth, with 20% of submissions arguing that there is currently too much wealth inequality in the world. One argument was that income inequality has increased dramatically over the past few decades, causing excessive suffering to large populations, and that if wealth is not redistributed, far greater will suffer. Another key point for the motion was that redistribution of wealth will allow those with less opportunity to achieve success. People also think huge wealth gaps lead to social unrest and decreased security for all. The remaining 44% were against the motion, with 15% of submissions arguing that redistributing wealth would discourage some people from working hard. One argument in support of this is that redistributing the wealth discourages individual initiative, entrepreneurship, and accountability for choices. Please visit the website to see the full results. Good luck to the human debaters.
All right, and as we continue with the human debaters, it was interesting to hear the global audience hitting on some of the same dividing lines, but there was one I want to zero in on that was brought up in that analysis that we haven't heard, whether there would be a behavioral impact on those whose wealth would increase as a result of a redistribution, that it would discourage the desire to work. Let's take that to you, Yanis, that there would be a moral hazard to redistribution of the wealth. What's your take on that?
If you're interested, you can see the full results in the link shown on the screen. The last event that we made with Speech by Crowd was the Grammy event this year. And also, if you will search it in Google, you can find and see. After the debate, we aim to extend the project debater technologies to other natural language problems. We split project debater into a set of separate services, such each service is a single Lego brick. And as I said in the beginning, by combining these bricks together, you can build a very complex application that we believe can address many, many different use cases. And these services are available in the project debater early access program. And so let's discuss it now. The Early Access Program is available freely for academic use in the IBM Cloud and can also be licensed for commercial use. We built a Python SDK, which enables easy use of our services inside the Pythonic framework, and all the services are REST-based, and which enables the usage by any desired programming language. Let's review the services. Overall, we released 12 APIs, which can be divided into 3 groups. The first group is the core natural language understanding services. The first one that I will mention is the text wikification service. This service gets a text and returns a list of mentions of Wikipedia concept in the text. For example, if I will run it on the text, cars should only assist drivers, since self-driving cars are too dangerous, it will return the mention self-driving car with link to the Wikipedia concept self-driving car. But if we will run it on other phrasing of the same sentence, something like cars should only assist drivers since autonomous vehicles are too dangerous, then again, it was linked autonomous vehicles to the same concept, to self-driving car, which is a Wikipedia title. And that's how it's enable you to identify similar concept even when using different phrasing. There are many other in the world wikification tools. For example, there is the famous TagMe. I think that the main difference between our tool to the other tool is that our tool was made for large corpus. So it's very, very, very fast, much more than other tools. So for example, as I said in the beginning, we indexed all Wikipedia and LexisNexis, which is a huge corpus, and we run this wikification tool on the entire data set, and it's totally achievable. So I really recommend try it. The next service is the concept relatedness service. This service gets 2 concepts, which are Wikipedia titles. Many times it's pipelined after the service that I just presented. And the service returns a score between 0 and 1. And this score predicts the relatedness between the 2 concepts. For example, we can check the relatedness between dog and bulldog and expect it to be high, to be close to 1. But if we will check dog and chair, we expect the score to be low. This service is based on BERT, and we train it on a data set that we collected. Another service in this group is the text classification, text clustering service. This service based on SIB, sequential information bottleneck algorithm. And this is very efficient text clustering algorithm, both fast and good result. I think it's much better than k-means or something like that. And I want to say that in addition to the service, we also published, we put it in GitHub. So everyone can use it as a Python package. You can look at our website if you are interested. And the last service in the group is the theme extraction. This service received a clustering partitioning of text, and it's returned a list of themes, a theme for each cluster. And this is exactly the service we used in order to identify the theme of each cluster in the real live event. The second group of services addresses the core capabilities of project debate, identifying arguments, which are claims and evidence, analyzing the stance, and assessing their quality. The claim classifier gets a text and predicts whether it contains a claim or not with respect to a topic. The evidence does the same for evidence. And the next service is the stance classifier, which predicts the stance of an argument to the topic. I will elaborate a little bit more about it next. And the last service in this group is the argument quality service that tries to assess the quality of an argument with respect to a topic. The last group is about context summarization. We have here narrative generation and keypoint analysis, which are two high-level services that create different types of summaries. First, I will describe narrative generation. When it gets a list of arguments and it's construct a speech that supports or contests the topic according to the specified polarity. The keypoint analysis is a unique summarization paradigm that includes an important quantitative angle. This service summarizes a collection of comments on a given topic as a small set of automatically extracted human-readable key points, each assigned with a numeric measure of its prominence in the input. It can be applied in different types of opinion text, such as user reviews, customer feedback. And the next talk in AI camp, at least from our group, I don't know the entire schedule, we'll show a hands-on tutorial of how you can use this service in order to analyze the free text survey. In addition to all the services, we also have a sentence level index of Wikipedia. If you are interested and you want to experience with the early access program, you can do it freely. Just just browse to the link shown on the screen and log in as guest. If you want to use it programmatically, we have both Java and Python SDKs. You can simply download the SDK from the site. And in order to run it, to use it, you need an API key, which we provide free for non-commercial use. If you are interested, mail us and we will give you the API key. This is how the early access program website looks like. The main tab of the site includes a detailed description of all our services in the left. Each service has a short description. And if you want to read more, you can expand it. And it includes the links to academic references. So if you want to understand, we have many academic papers that we wrote when we developed these services. And if you're interested in each service, you can see the link to all the related academic references. For each service, there are Python, Java, CURL code example. And in addition, there is a demo UI, which enables you to try the service directly on the web. So for example, here, this is the claim detection. You can write a sentence and a topic and click the get score and see the score it gave you, and you can try it and explore it on the web. In addition, there we have a tab that includes example for end-to-end use cases. The first example is mining to narrative, where we show how a short set of code segments, you can mine arguments from Wikipedia and analyze them and aggregate them as Proco narrative. The second example demonstrates how to use the early access service in order to analyze a massive amount of textual comments collected in a survey run by the city of Austin, Texas. We also, as I said, have the SDKs if you want to download them. And finally, there is the speech by crowd application page, where you can see instructions for a speech by crowd. Everyone can use free speech by crowd. So for example, if you want to open a topic and share it with your friend and ask them to contribute arguments, and after you collecting all these arguments from your friends, you can generate a narrative from it and share the narrative with your friend. It's really nice, and you can try it. And in this tab, we have explanations and short videos that show you how to do that, how you can add arguments, how you can create a speech, and how you can share it with your friend. Very important feature of many of our services is the ability to fine-tune them. The services originally trained on hundreds of thousands of examples, but sometimes we want to use the services in specific domains where the example we expect are a bit different than the example that it was trained on. The difference can be caused by the style, the topic, or any other linguistic feature. If you are able to collect labeled examples with the feature that you expect to have in the real input, you can use them to adapt the service. Even few dozens of examples can significantly improve the model's performance. For example, the graph that we see here is from I think that's from the Grammy event, and the blue line is the performance of the system on the original model, and then we fine-tune it over 500 examples that we collect before the event, and there is the green and the orange line, and you can see that they have something like 10 points in precision better than the original line with only 500 examples. It's very easy to fine-tune the services. You don't need to run any code in order to do that. The only thing you need to do is to first collect the data, put it in a CSV file, as you see here. For each service, there is different inputs. But for example, here we have the inputs of the Procon service. So the inputs are examples of argument, motion, and the label. Each service has a UI connected to it, and you just browsing the UI, uploading the file, give new name to the new model, and start train it. After a few minutes, you will get the new model, and you can use it. Of course, that the early access program on the web is shared between all our users, and that's why we don't allow anyone to fine-tune the official services, but instead we enable our customer to get Docker images of many of our services and then to fine-tune them on the user's machines. If you will do that, if you will run our services on your machine, it have few advantages. First, it's enabled the fine-tuning. Second, the data will stay on your machine. And if you have any sensitive data that you don't want to share with us, it's totally fine. And it's enable you to keep the data on your machine, but still using the early access program API. And third, of course, that these services demands a lot of resources, and we have many users. So for each user, we limit the amount of requests that we allow to use. And if you will use it in our machine, you can use any scale if you have enough resources. In general, on the cloud, on our cloud, we use the GPU machines. We actually use NVIDIA K80, which are 5 times faster than standard CPU. But we can give both CPU-based and GPU-based Docker images. So if you don't have GPU and you still want to run it on your machine, it's totally possible. Okay, so in the last part of this talk, I will try to discuss just on the tip of the fork some tree services, a little bit more. I will focus on keypoint analysis, pro, con, and argument quality. I will start with the keypoint analysis service. As I said, this service allows you to take lots of opinions, short text of opinions, and to analyze them. And the way that it works, it extracts the main key points of these arguments and give it to you. So let's say that you do a survey and you have 5,000 responses. And of course, that no one wants to read 5,000 sentences of text. It's something that many people can do. But if you will give it to the machine will find the main key points, short list, many times less than 10. And for each key point, you will be able to know how many arguments were mapped to this the key point. And you can also see the matched arguments if you are interested. And that's how you can read and understand a lot of data shortly. I will first want to show you an example of the technology. We applied on a customer customer complaints data, and we started with a few dozens of thousands of examples, and you can see here that with only 6 key points, we covered more than 50% of the data. So I think it's really usable. Please take a minute to read the key points to feel it. So just a few words in very high level how it worked. So we starting from the list of arguments, and the first step is to find the candidates of the key points. And we first find the shortest arguments, since key points, in order to be generic, must be short. And we also verify that they have high quality, and we do it with our argument quality service. And then we get a list of key points candidates. Then we sample the entire set of arguments, and we try to match these arguments to the entire key point candidate list. In order to do that, we are using a matching model, which based on BERT that we trained. And in addition to the matching, we try to merge similar candidates to a single key point. Then we take the top K candidates with the most matches and say that this list is the key point list, the selected key points. And then we match the entire set of arguments to this key point list. And after we do that, we give the output, which is the matching, and that's it. Next, I will discuss a bit the pro-con service. As I said, the pro-con service is used to predict the stance of an argument with respect to a given topic. It receives a list of arguments and topic pairs and return a list of score between -1 to 1, where the absolute value of this score represents the confidence of the machine in the result, and the sign represented the class. If it's negative, it means that it predicts that it's opposing the topic, and if it is positive, then it is supporting the topic. It's based on BERT, and the base model has been trained over 408,000 examples, both from speech by crowd and claims and evidence from LexisNexis. As I said, the score that it retains is between -1 to 1. So a naive approach, in order to use it, is just to look at the sign of the result without taking the absolute value into account. Of course, that this is not enough, because many times you have a mixed stance arguments or just arguments that the system is not confident enough. And if you will classify it, you will get not enough high precision. So what you can do, the simple thing to do is to define a threshold and classify only arguments that their absolute value is higher than this threshold. And all the arguments that their absolute value is less than this threshold, don't classify or say that they are neutral. In this way, you will get higher precision, but you will not, of course, classify the entire set. So you can, by selecting the threshold, you can trade off between the coverage and the precision. The last service that I want to touch in this talk is the argument quality service. And we use it in order to predict the quality of an argument with respect to the topic. For example, here on the screen, you can see 3 arguments addressing the topic we should adopt cryptocurrency. And we can see that the first one is clear and reasoned. The second one is much less clear, with grammars and spelling errors. And the third one makes implicit irrelevant justifications. I think that we can agree that if we are working on a speech that try to persuade for some topic, we should prefer the first one over the others. So how we build this service? We used a BERT-based service, a regressor, and we train it. The question is how to collect data. And when we tried to do that, we faced many problems. Like, what is better, cleared or well-reasoned argument, short argument or long one? Many times, if we will ask 2 people, one will say that A is better than B, while the other will say that B is better than A. And in order to answer all these challenges, we choose a holistic approach with binary classification. For each example, which was a pair of argument and topic, we ask people to say whether they recommend using the example in a speech, and then we average what they said as the score of the example, and we use it to train the regressor. So this is about our services, and I'm almost finished. I just want to say that then we will give another talk, which will be more hands-on experience on how to use the Keypoint Analysis service in order to analyze free text. And in general, I want to invite all of you to take a closer look at Project Debater. If you want, you can explore the Early Access Program website that we discussed. You can read the Nature publication if you are interested, or you can view the film. I really want to thank you for joining me today. So thank you very much. And if you have questions, maybe it's a good time.
Great. Thanks, Elad. That's really impressive with the project debater. Amazing to watch the live debating. Let's, I see we have a lot of comments on the questions in the chat. Can you open it up? We can go through them from the top to the bottom.
Don't see how I see the chat. See?
Yeah, there's a chat button. You can just close it.
Yeah. So someone asked, Elad, can you please tell a little about the hardware resources behind that? It is large GPU cluster. Okay, so thank you for the question. So there was a big difference actually between the live event and what we have right now. In the live event, we had a monolith system that we ran on a CPU-based machine, and actually the entire system ran on a single machine. And we had few duplication just in order to increase this. We don't want that if some machine will crash, we will not have any backup. But actually, the entire system runs on a single CPU machine. Right now, we have many GPU machines based for the early access program website services. And we change the amount of machines depends on the usage. So that's how we do right now.
By the way, just a quick reminder, please post your questions in the chat. We are run through the Q&A right now. And if you prefer to speak to ask questions, you can raise your hand. You can, unmute yourself to speak. So please go ahead. I see a few comments from the top. One from Emmanuel from USA. He or she is mentioned about fascinating, about impressive. It makes me wonder the future of AI and public opinions will be influenced by AI.
Sorry, can you please repeat the question? I'm not sure.
Basically, she or he is asking the future of AI and public opinion, will we be influenced by AI?
Yeah, I agree that we will all be influenced by AI, but I think that our hope is that the machines will augment us and not rule us or take our place. And I think that Project Debater show exactly that. I think that the conclusion of the debate was that still there are things that humans do much better than machines. And actually, persuasion is one of them. But I think that when we want to make a decision, many times we want that it will be based on facts. And I think that find this fact is something that machines many times can do better than humans. So I think that what we want is to use the machine in order to enrich what people know and to make their decision smarter and more aware to what there is.
Yeah, I think as another attendee's comments, the public opinion influenced by AI is not the future. It's already here already. See some of the social media use of AIs. I see there when attendees raise hand. We'll just hold on a second over there. Let's continue some of the questions on the chat they posted before. The next one, maybe, if we just easier, I can read to you, is from you finish. I apologize for many of person I probably pronounce the name is wrong. We know speech-to-text recognition systems are better at recognizing Eurocentric or Queen's English voice compared to more accented or colonial English. Did you test with speakers with different accents?
Yeah, so actually the text-to-speech was part that we give a lot of attention because we believe that it is, if you want to sway, this is very important part of the system. So we did many experiments. We tried different voices, and we choose an actor that made that we record, and the speech, the text-to-speech service was based on her voice. And actually, this was not my team that did that, but it was part of the system. And in general, the speech-to-text, I hope that you convey when you listen to it, it was very expressive. There was a lot of marks that we add in order to emphasize the claims. And so it will feel natural. So I hope it answer the question.
Another question is from Yanis. He or she is asking, can your platform difference between text and that was created by an actual human was text that was created by a machine?
Yeah, so in general, the debate, all the text was created by humans, actually. There was no text was created by machine. There was no speech, actual generation. As I said, there were two main sources. The first one was the generic argument database, which was a scripted text, but it was huge corpus that the machine decided which argument is related according to the category, as I described. And the second was mine arguments from newspapers. So let's say that you take all the newspapers and magazines for the last 10 years, and you find relevant arguments. So the machine find the arguments and allocate them in the speech, but people wrote these arguments, right? The journalist who wrote the article.
Another question is from Soma from Canada. He is asking a very interesting question. What happens when the AI debates itself? Is there a pros cons bias?
Yeah, so it is very interesting question because as I mentioned, it was one of the challenges that we faced because in many systems, the best way to train it is train it against yourself and then you will improve. But what is the meaning of debating against yourself, right? The debate, as I said, takes arguments from mind arguments based on motion. So this part will be shared for the both sides, right? Pro and cons, you will get a different set because for pro and con, you will get different answers, but it's fixed set of arguments that you will have. After that, the rebuttal is based on the analysis of the opponent's speech, and then you try to anticipate the claim. And I think that the question is how you will know that you do something right or wrong, right? Some human needs to verify and check whether the system correct or not. And that's why it was impossible to train the system against herself.
Okay. Next question from Yanis. How can we know your software is not spyware? I think it's he or she is mentioning about the listening part. Some like Alexa or the other
So
voice
first,
device. Sometimes they.
Yeah, I totally understand the question. So the listening comprehension part was only in the debate configuration, which we finished. It was done in 2019 in the Grand Challenge, and we demonstrated, and we don't have anymore the listening comprehension part. So if you ask if we collect data when you send us arguments, so the answer is totally no. We really take into account the privacy issues, and but of course that and sell it or something, do something totally.
All right, I still see we have quite a lot of questions over there, so I have to maybe just pick some of them. I think one is from this one. Could you please tell us a little bit about the hardware resource behind that? Is this question already answered? It is the largest GPU cluster.
I think that we discussed this question.
Okay. Another one is after that is what's the main algorithm used in debating?
the main algorithm. There was no main, that it was a long pipeline that I tried to describe. And each part was very important, right? If you don't find good argument when you query the index, then you can continue. If you find a lot of sentences, but you can't identify the real arguments out of the other sentences, it will not be enough. If you fail the stance detection, then you argue against your own position. So it will be very bad. So every step was critical. It was very, very complex system. Without single algorithm.
Okay, let me plug in another question you sent to me, and I think it's very interesting. Right now, did you see any like the future of or any plan for this project Debater to integrate with Alexa or Google Assistant, Siri? I mean, right now all of those those devices, they are pretty simple and sometimes dumb, boring. Ask questions, they tell you answers or no answers. But with this one, seems like it's have a lot of features to enhance those communication between the human being with the machine and with the device.
Yeah, I totally agree that this is a very interesting question. I think that it was very hard. As I said, currently we don't have the listening comprehension. It was part of the debate system. But for the debate system, it was very hard because unlike Alexa get a simple command and you just need to understand the command, which is one sentence in general. Even many times it's one word or two words. In our listening comprehension, we have to listen to a 4-minute speech and to understand whether it contains the claims that we find in huge corpus. So it is totally, we have to understand the gist of these 4 minutes. So I agree that this is something totally different, and but currently we are not, we didn't continue with the listening comprehension capabilities, but we have the early access program, and we really believe that everyone can use it, and in order to in their natural language problems, and that's it.
Okay, yeah, great. And I think if some way to integrate that going to be greatly enhance the current all of those voice device. Yeah, even for my personal experience, for those Alexa, Google Assistant, even Siri, just like one questions, they return the answers. Then you cannot it's very hard to send a follow-up questions, or sometimes in the correct the questions. But anyway.
There was one interesting one, if I may,
Sure.
from I think I guess from Canada, Ushnish. He was hinting at making the point that the debate is a very British system, and there's other indigenous communities that are more organized around consensus building. And that was my question too. Do you envision a scenario where Debater could be used to facilitate consensus building or an exchange between opposing parties and bringing them closer together by maybe pointing them to areas where there is or could be potential agreement or collaboration or whatnot?
Very interesting question. So I agree that the debate was very restricted from math. I think that's why we choose it, because still it was very hard for machine to part of it. I think that the main idea of the debate, that the grand challenge, was to show that we have a lot of NLP technologies that related to opinions. What we can do with the technology, we're still exploring that. We have some tools like the Keypoint service that I mentioned before, and we believe that we can do a lot of things with it. Currently, we don't have what you suggested, which sounds very interesting. But maybe we can use these tools in order to achieve that.
Thanks, Elad.
Great. I think we are 20 minutes over time, but I just want to touch base the last questions from Corey, and I also he sometimes doing. I'm not sure he's doing a side language or do some things. So, do you want to just speak? I see you put quite a lot of text, so instead of I read it, maybe you can just unmute yourself. Yeah, just speak.
Yes, can you hear me okay?
Yes, go ahead.
Okay. I had a couple questions, but I think the most interesting one I had was, can the system propagate the feelings of human sociopathology and affect by the conversation? Meaning, when I'm speaking to you and I say something appalling, you go, and then instantly my brain picks up on the shock wave coming off of you, the intensity of that as to what to say next. Can the machine ever learn that by tone and vocalization? Is that something that was ever looked at before?
I hope that in the future we will, but during the event we didn't. The event was actually very technical, as I just described.
Yeah, it was. I've seen it had a lot in there, more than I thought was going into it. So,
but I mean, it didn't take emotions into account almost at all. I think that it was, for example, we add humor, and
humor is the basis for all of the inequality that the machine has to the person, and that's very important. You must realize that the machine can't really cross that barrier, because if it does, what's the difference between me going off on a conversation or just me going home and talking to my robot all day? In the future, it's kind of needed.
I think it's a philosophical question. I totally agree that this is something
deep, but
if the machines, I think what the debate demonstrated was that, for example, take humor as an example. So we had lots of jokes in the debate, and we add them. We had a component that they was written ahead by humans, but the machine, there was a lot of jokes, and the machines tried to match the joke to the situation. And it was very technically, right? If we talk about poverty, then the machine says that since it is a machine, so she didn't care about
massive amounts of data. Like, that is grand, man. You really don't understand how the advent of technology being so fast and quantitative now, and so much of the data is in there, that you guys have developed a system that can identify all of those data sets, and it's amazing. It really is what you guys have built.
I agree, but I think the other side is that I think that most of the time it was okay. Sometimes it was very embarrassing because the joke were not in place.
No.
Many times it was okay, and it was, actually it's a
machine.
I started to think, everyone do that. If you say the word, then you have a link joke that you always, if you talked about X, then you have the corresponding joke. And
yeah, that's the basis of a joke. A joke is like either A or B. It's either yes or no or up or down. And the machine was like, I'm neither up or down, and here's my response. You spoke about this, and it's technical, like you said. That's great. I'm actually developing a game myself, and I'm an up-and-coming development company. And with what we're trying to develop right now as an MMORPG, we're redefining the stage for MMOs and the stage for computing power. Is there any way to integrate your guys' system into a speech engine? Like, if I wanted to go out and debate politics with the NPCs of this world that we live on in the game, could I do that with your guys' system?
I think it's worth to try. I think that I really recommend you to look at the early access program website and look if the tools there can suit your needs. And actually, no one's right. These are tools. These are Lego bricks, like I said. And I hope that you can build very, very complex building from these bricks. I don't know which building, but we can help find out. So I really...
It would be basically a tagging system, whether you gain reputability or lost it with that person. depicted on what flag you carried with you at the time. So that's kind of like how politics works. Like, oh no, the gruntledness, and then yeah, I think we could really benefit several ways from this, or like it would go into that. And I think I saw like I didn't have that idea before this, seeing this, but seeing what your system can do really did bring a new idea into what I was trying to make the game do anyway. So it offered a system of relief to me. And I just want you guys to know, like, if there's any way we can work together in the future, I will definitely get a hold of your manager, your IBM Debating Technologies manager, and try to see what he says.
So please mail us.
Great. Yeah. So I think that's sounds great. So I mean, I think we have some follow-ups. You can follow up with Elad and to also check their early access programs. I'm pretty sure there's some collaboration opportunities. Unfortunately, we have to stop here, and I still see some of the questions, comments in the chat. We cannot cover today. Fortunately, we have already scheduled another sessions. The workshops actually to go deeper into the project debate systems, how to use it, and some of the access APIs. So I do strong recommend you go to sign up over there. I just posted the link in the chat, so that is on June 30th. Yeah, feel free to register over there. With that, it concludes today's event. Go ahead. Sorry.
I just want to say that if someone still has question or clarities that you want, please mail me. I will be very glad to answer.
Okay.
Yeah. Yes. Absolutely. Absolutely. Feel free to to reach out, and also the